So let's go over speed and velocity. And so average speed is distance divided by elapsed time. Average velocity is change in x divided by change in time. So average velocity is displacement. Average speed is distance. Instantaneous velocity is the velocity in a specific instant. And magnitude is the instantaneous speed, which is shown on the speedometer. So pretty simple logic here. I'm going to come over here and I'm going to illustrate how we derive the certain formulas. So average speed is the same thing as average velocity if we're assuming we don't go back. So average speed is how much we actually traveled or how much we actually went, while average displacement is or average velocity is how much we actually went in one that direction divided by time. So the reason why we divide it by time is to evenly split up the distance we went over the time interval. So let's say we traveled 5 seconds, or we traveled for 5 seconds and we went 20 meters. That would mean we went 4 meters per second because we're evenly splitting up the 20 into 5 groups. It's basic, simple arithmetic and algebraic operations, which I actually made a video on. But average velocity works the exact same way, except we use displacement. So again, for a refresher course, if we travel 5 meters here and 5 meters back, technically, using distance, we traveled 10 meters. But using displacement, we traveled nothing because we were back at our original position. So same thing, same concept. Now here's where it gets a little bit tricky. We have instantaneous velocity. And instantaneous velocity is how fast we're traveling at one instance. I don't know if I spelled that right, actually. I'm kind of tired right now. So let's imagine a car, and a car never travels at one constant speed. There's traffic, everything. I keep using this analogy, actually. So at one point it can be traveling 35 miles per hour, and another point it can be traveling 70 miles per hour. So the instantaneous velocity is how fast it is traveling at one instant in time. Now the reason why the formula is delta x over delta t, or displacement over time, as delta t approaches 0, is because that captures that one moment in time. Because if we did 1 moment in time, we can't travel 0 distance, or we can't divide by 0. So the closer we get to a very, very short instance of time, that can be considered instantaneous. So that's as delta x is approaching 0, which is actually the derivative definition. So there's the derivative for you in simple terms, how fast something is moving at a specific point in time using the slope formula. But here it's just how fast we're moving divided by very small instance of time to be extremely precise and accurate. So that is speed and velocity summed up. So